This is lesson 4.5 on volume of a cylinder. Before watching the recording, please make sure that you have either a graph sheet of paper or your math journal in front of you, along with a pencil, a straight edge or a ruler, and perhaps different colored pens or highlighters. So if you need to pause the recording to get those items, please do so now. Go ahead, if you are ready, set up the date at the top of your page. The lesson number is 4.5. You may also at this point want to pause the recording and come up with your own understanding and definition of area. Before this lesson and leading up to this lesson, we've dealt with area, primarily the area of a circle. So what is your definition of area? If you want to pause the recording and then check in with the definition and resume the recording when you're ready, please go ahead and do so. So if you think about area, think about it in terms of the amount of space a two-dimensional object takes up. As part of your definition, also think about the units of measurement that it's typically measured in. So we think that it's measured in millimeters squared, centimeters squared, meters squared, kilometers squared. So really the units that we deal with when we measure area are squared units or square units. Oftentimes, when you're dealing with, say, a parallelogram or a rectangle, you're multiplying two dimensions. And area only measures two dimensions. So if you want to, as a reference, just highlight the square units that it's measured in. Now, moving on to volume, there is a difference in terms of what volume measures as opposed to area. Again, if you want to pause the recording and come up with your own definition of volume so that you have your own understanding and you form it, go ahead and do so. I'm going to continue. Now, the difference between volume and area is that the volume of an object is only reserved for three-dimensional objects. So we're still talking about space, but we're talking about the amount of space a three-dimensional object takes up. So volume is the amount of space a three-dimensional object takes up. Now, also consider the units of measurement and volume because there is a difference too. You could have millimeters cubed, you could have centimeters cubed, or meters cubed. You wouldn't really have kilometers cubed. It's not a very common common unit of measurement for volume, so we'll leave it at those three. So volume is measured in cubic units. And if you look at the example of, say, a rectangular prism, technically you're multiplying out three dimensions because it's a three-dimensional object, so there are three dimensions to consider. That is why we end up with cubic units. I'll highlight that. So again, volume, we've got the units of measurement are cubic, and we've got cubic units. The other thing we should also highlight is three dimensions versus two dimensions. Those are important things to understand. Now, looking at area, if we know that area is only measured in square units, it's a two-dimensional object. We look at volume. So first, let's talk about a rectangular prism because it's easier to see this first. Now, we're going back to a rectangular prism because in a moment you'll see why, because we're going back to a rectangle, the area of a rectangle being measured by the length and the width. So go ahead and use a straight edge and draw out a rectangular prism, like what I'm going to do here. And you can do the same thing. I do like doing this on graph paper because I have a guideline as to how to draw the 3 dimensions, it's a little bit easier. What I'm also going to draw out is the base so you can see it. Or the area that you can't see to make it look more 3-dimensional. So when you think about it, remember that the area of any rectangle, you would typically have the length. You would have the length times the width, right? Now notice we're dealing with rectangles. So we've got the length times the width. So the length and the width would actually give you that base area. But now we have a 3rd dimension, and I want you to think to yourself, what is that 3rd dimension with a rectangular prism that we're dealing with? That 3rd dimension is known as the height. When we're talking about a rectangular prism, notice that we're not talking about, I'm not throwing in parallelogram here not to confuse you. So we're dealing with a rectangle. We're back to length and width for the base area, but now we've got the height element. So we've got 3 dimensions we're dealing with. We've got the height, we've got the length, and we've got the width. Okay, so really when you're dealing with the volume, we want to find out the amount of space the entire prism occupies. We're dealing with, again, the amount of space the entire prism occupies. So I'm going to just highlight that in. We want the volume of this entire space, right? So when we look at the volume, we really want that base area, which is the length and the width, times the height. And so what happens is that base area is the length times the width times the height. So it's length times width times height. Okay, so I'm just going to be in brackets, base area, length times width times height. So really V equals L times W times H. Okay, if you want to just box this out, this is important to remember, and remember we're going to apply this anyways, because you do have to remember how to apply the formula of the volume of a rectangular prism. Because it's 3 dimensions, remember we're going to have cubic units in our answer. Okay, now that's the rectangular prism. Our focus today though is the volume of a cylinder, so we'll move on. A cylinder is also 3 dimensions too. The same principle, we're going to have the base area and the height. Now, let's draw this out. So let's go with the cylinder here. Okay, so a cylinder. Okay, so the cylinder we have here, we've got, okay, it's not going to be super accurate, but that's okay. Okay, then we've got, I wonder if I can get this straight, maybe not. Okay, I will try my best here. Maybe that's not going to work. What I'll do is I'll probably just draw the bottom, and then I'll just do a dotted line because typically you wouldn't see the other side. So there you go. Now we've got a cylinder. Now, the cylinder now may not look like a circle, but it is a circle on the bottom. So let's look at this base area again. Remember, what do you know from calculating the area of a circle? So the base area is really the area of a circle So think to yourself, what is the area formula for a circle? You know that it's, okay, jot it down, pi r squared, okay, as in the previous lesson. So the base area is pi r squared. Now, similar to the rectangular prism, you have that added third dimension, which is also called the height. And then similar to what we did here above with the rectangular prism, you have to multiply that base area. With the rectangular prism, it was a length times width times the height, which is the third dimension. So think to yourself, what do you think the volume of a cylinder formula will be? Well, you would think that it would be very similar to the rectangular prism, because all you're doing, again, the volume, if you think about it, is going to be also the base area times the height. Now in this case, we have a cylinder though, and with a cylinder, you've got two circular bases. So you have to take the area of the circle and multiply it by the height to get the entire volume of the whole of the cylinder. So knowing that the base area, in this case, it is pi r squared, as we said before. The base area is pi r squared times the height. So the volume, I should say, of a cylinder, the formula that you're going to apply is going to be pi r squared, which is, again, the area formula for the base, which is a circle, times the height. So we write it as pi r squared h. So all you're doing is you're multiplying, again, the base area times the height. And your units are also going to be cubic units. Remember, the units of measurement are really important. Okay, units of measurement are extremely important. Okay, so let's apply this with one problem. Okay, so again, here we go. Number one. Let's do, okay, find the volume of a cylinder where the radius is 3.2 centimeters. And then now I also have to give you, and the height, you have to be given the height here, is 5 centimeters. Round your final answer to 2 decimal places. Okay, so again, you should know by now what is the very first thing you always write down when you have a formula you're going to apply. You always have to write down the formula. So pi r squared h. And then equals. Again, you should know by now, what is your next line going to look like? You have to have a substitution line. So you're going to recopy pi, and you have to do a double substitution here. You know that your r, your radius in this case is 3.2. You know the height is 5. So you're going to substitute both of them on the same line in separate brackets. So we know radius is 3.2 centimeters. Make sure you're substituting the units of measurement too, squared, times. You're going to substitute 5 centimeters, also in brackets. Now, this is really important too, and you can write this off on the side. You have to apply your order of operations here still, because again, think to yourself, what are you going to solve first? You have to solve the exponent first. So in this case, You can take your calculators, and actually at this point, why don't you pause the recording and see if you can figure out the answer on your own before checking it with what I have here. I'm going to continue. 3.2 centimeters squared, so 3.2 times 3.2. Oh, I can take this out of brackets. 3.2 times 3.2 gives me 10 and 24 hundredths of a centimeter squared. Please make sure that this is centimeters squared here, okay? And then I'm going to keep 5 centimeters in brackets. Now, I should mention here, you should show this step. This is, because remember, you have to take the square out of the brackets or the exponent out of the brackets and show this step. You should be showing this next step. Now, in terms of this final step here, you could multiply pi times 10.24 centimeters squared times 5 centimeters. But this is where units are really crucial. So again, if you want to pause the recording and just check to see if you're on the right track, after you figure it out, go ahead and do so. So I'm going to do pi times 10.24 centimeters squared. I'm typing this in my calculator right now, times 5 centimeters. Now, I see on my calculator, I get, what are we at? I have 160.84954, etc., etc. And this is centimeters cubed already because remember, our final answer has to be in cubic units. Now, the reason why, if you think about it, centimeters squared is in the third line times centimeters. So you're actually multiplying a third unit of, a third dimension, which is why you have cubic units. Now, it did ask you to round your final answer to 2 decimal places. So I know that my final answer, looking at that, is 160.85 centimeters cubed because the digit in the thousandths place is a 9, and that forces the digit in the hundredths place to round up to a 5. So that's how you apply the formula right there. Make sure you show all steps here. You should be showing all the steps here, the substitution, the next step after you take that exponent, and make sure you have centimeters squared here times centimeters. Your final answer has to be in cubic centimeters. So to review, make sure you understand the concept of volume and how it differs from area. Let's look back at the top. We know that area measures the amount of space a 2-dimensional object takes up. Volume refers to the amount of space a 3-dimensional object takes up. Don't forget the difference in terms of the units of measurement with area because we're dealing with 2 dimensions. The units are square units. With volume, because we're dealing with 3 dimensions, the units are in cubic units. We looked at a rectangular prism. We looked at the volume of a rectangular prism having 3 dimensions to calculate. So it's the length and the width, which is the base area times the height. A cylinder has a circular base. So the area is calculated differently than as in a rectangular prism, but the concept of volume is still the same. You still take the base area times the height, but in this case for a cylinder, the base area is pi r squared, but you still have that third dimension of height that you're calculating in there. So the volume of a cylinder, the formula is pi r squared h, h standing for height. And again, to apply the formula, make sure you're showing all the steps thoroughly and that you're applying the order of operations and calculating that exponent or the squared part first.